You know, when you check the weather, or you're cooking something, or you're just feeling a little under the weather, it all really boils down to two key ideas: heat and temperature. We use these words all the time, but the difference between them can be, well, a little fuzzy. So let's jump right in and clear all of that up.
All right, let's get right to it. This is the big question that trips so many of us up. We tend to use the words heat and temperature as if they're the same thing, but in the world of science, they're absolutely not. So, what is the real difference?
Okay, here's how to think about it. Heat is all about the total energy in something. It's the combined energy of every single molecule moving around inside an object. So, get this. A huge, lukewarm bathtub actually has more total heat energy than a tiny boiling hot cup of coffee. Weird, right? But temperature is the average energy. It's a measure of how fast those molecules are moving. So even though that little cup has less total heat, its molecules are zipping around like crazy, which gives it a much, much higher temperature. So if temperature is a measurement, how do we actually measure it? I mean, we need some kind of tool that can look at all that molecular movement and turn it into a number we can actually read. And that, of course, is where the thermometer comes in. Let's take a look at how this brilliantly simple gadget actually works. So a classic thermometer really just has three main parts. You've got the glass bulb at the very bottom, which is like a little reservoir. Then there's that super thin glass tube running right up the middle. And inside, you've got a liquid, usually that shiny mercury, that reacts to even the smallest changes in heat. The whole thing works because of one simple, beautiful principle: expansion. When that little bulb on the bottom touches something hot, the mercury inside soaks up the heat and it expands. And because that tube is so incredibly narrow, even a tiny bit of expansion forces the liquid to shoot way up. The little lines on the side of the glass, they just let us put a number to that reaction. It's just such a simple, elegant way to get a super precise measurement. But, those markings are just numbers. If I say it's 20 degrees outside, that's totally meaningless unless you know which temperature language I'm speaking. So let's decode the three most common temperature languages that we use all over the world. Now, what's so clever about these scales is that they're built around something everybody on Earth understands: water. The Celsius scale is super logical. It sets the freezing point of water to 0 and the boiling point to 100. Easy. Fahrenheit does the same thing but sets those points at 32 and 212. And then you've got Kelvin. That's the one scientists use. It's based on the idea of absolute zero, the coldest anything could possibly get, where all molecular motion just stops. So, just like we have different scales for temperature, we also have different kinds of thermometers. And it makes sense, right? You wouldn't use a big meat thermometer from your kitchen to see if you have a fever. Every thermometer is designed for a very specific job. First up, we've got the one we're all familiar with: the clinical thermometer. Its one and only purpose in life is to measure the body temperature of people. That's it. And because of that one specific job, it's designed in a very particular way. This special design is exactly what makes it so good at its job. A clinical thermometer has a really narrow range, usually from about 35 to 41 degrees Celsius. Why? Because a living person's temperature almost never goes outside that little window. By focusing only on that small range, the markings can be spread way farther apart, which lets you get a much more accurate reading. The magic number here, the benchmark we're always looking for, is 37 degrees Celsius. That's what's considered the normal temperature for a healthy person. So if your temperature starts creeping up above that, it's a good sign your body is fighting something off. In other words, you've got a fever. Now, let's check out its counterpart, the laboratory thermometer. Just like the name says, this is the workhorse of a science lab. It's not a specialist at all, it's a generalist. It's built to measure the temperature of all kinds of things: liquids, objects, you name it. And its range tells you everything you need to know. It usually goes from 0 to 100 degrees Celsius. Do those numbers sound familiar? They should. They are the exact freezing and boiling points of water, the very same reference points that the Celsius scale is built on. This makes it the absolute perfect tool for a lab. Okay, so we've covered the theory, we've looked at the tools. Now let's bring it all home and talk about the most practical, personal use for all this: taking your own temperature. How do you actually do it the right way? And, more importantly, how do you do it safely? The whole process is pretty straightforward. First things first, always clean a thermometer with an antiseptic. Then you place the bulb part under your armpit and hold your arm down tight against your body. Now here's the most important part: patience. You've got to leave it there for about 3 minutes to make sure you get a good, accurate reading. Then you can carefully take it out and check the result. All right, hang on. We need to pause for a second because this is really, really important. We have to talk about safety. That mercury inside the thermometer is fantastic at its job, but it is also a highly toxic substance. You have to be extremely careful when you're handling a mercury thermometer.
So let's be crystal clear about what to do if one ever breaks. First, and I cannot stress this enough, do not touch the little silvery balls of mercury that spill out. It can actually be absorbed right through your skin. You need to get an adult to help immediately so they can clean it up and get rid of it properly. And if you do happen to touch it by accident, wash that spot with soap and water right away. When it comes to mercury, it is always safety first, no exceptions.
So there you have it. From the big idea of total energy that we call heat to the precise measurement of temperature and the really elegant tool that connects the two, it's how we understand so much about our world, from the weather report to our own health. So I'll leave you with a question to think about. What's the most extreme temperature you've ever personally felt? Think about the coldest winter day you can remember or the hottest summer afternoon. What was the number on the thermometer? And more importantly, how did that number actually